Hello everyone, welcome to chapter 10, and in this chapter we will learn about designing databases. And what we will learn inside this chapter: consistently define each of the following key database design terms: relation, primary key, normalization, functional dependency, foreign key, referential integrity, field, data type, null value, denormalization, file organization, index, and secondary key. Explain the role of designing database in the analysis and design of an information system. Transform an entity relationship diagram into an equivalent set of well-structured relations. And merge normalized relations from separate users' views into a consolidated set of well-structured relations. Choose storage format for fields in database tables. Translate well-structured relations into efficient database tables. Explain when to use different types of file organizations to store computer files. Describe the purpose of indexes and two important considerations in selecting attributes to be indexed. And again, system development lifecycle planning, analysis, design, implementation, and maintenance. Introduction part is about files and databases. And database design, file and database design occurs in two steps. Develop a logical database module which describes data using notation that corresponds to a data organization used by a database management system. Relational database module and prescribe the technical specifications for computers files and the databases in which to store the data. Physical database design provides specifications, and logical and physical database design in parallel with other systems design steps. And the process of database design is continuous, and 4 key steps in logical database modeling and design. Develop a logical data module for each known user interface for the application using normalization principles. Combine normalized data requirements for all users interfaces into one consolidated logical database module. And translate the conceptual ER data module for the application into normalized for requirements. Compare the consolidated logical database design with the translated ER module and produce one final logical database module for the application. And key physical database design decision include choosing storage format for each attribute from the logical database module. Grouping attributes from the logical database module into physical reports. Arranging related reports in secondary memory so reports can be stored, retrieved, and updated rapidly. Selecting media and storages for storing data to make access more efficient. And deliverables and outcomes. Logical database design must account for every data element on a system input or output. Normalized relations are the primary deliverable. Physical database design convert relations into database tables. Programmers and database analysts code the definitions of the database. Written in structured query language (SQL). And relation database module. What is the relation database module? Relation database module is database data represented as a set of related tables or relations. What's the relation? Relation is a named two-dimensional table of data. Each relation consists of a set of named columns and an arbitrary number of unnamed rows. And relations have several properties that distinguish them from non-relational tables. Entities in cells are simple. Entities in columns are from the same set of values. Each row is unique. The sequence of columns can be interchanged without changing the meaning or use of the relation. The rows may be interchanged or stored in any sequence. And well-structured relation and primary keys. Well-structured relation or table, a relation that contains a minimum amount of redundancy, allows users to insert, modify, and delete the rows without errors, inconsistencies. And primary key, an attribute whose value is unique across all occurrences of a relation. All relations have a primary key. This is how rows are ensured to be unique. A primary key may involve a single attribute or be composed of multiple attributes. And normalization and rules of normalization. What's the normalization? Normalization is the process of converting complex data structures into simple, stable data structures. First, normal form. Unique rows, no multi-valued attributes. All relations are in one NF. And second, normal form. Each non-primary key attribute is identified by the whole key. And third, normal form. Non-primary key attributes do not depend on each other. The result of normalization is that every non-primary key attribute depends upon the whole primary key. And functional dependencies and primary keys. Functional dependency, a particular relationship between two attributes. For a given relation, attribute B is functionally dependent on attribute A. If for every valid value of A, that value of A uniquely determines the value of B. The functional dependency of B on A is represented by E equals to B. And functional dependency is not a mathematical dependency. Instances in a relation do not prove the existence of the functional dependency. Knowledge of problem domain is most reliable method for identifying functional dependency. And second normal form, a relation is in second normal form if any of the following conditions apply. The primary key consists of only one attribute. Non-primary key attributes exist in the relation. Every non-primary key attribute is functionally depend on the full set of primary key attributes. To convert a relation into 2NF, you decompose